Okay, let's dive right into this explainer. If you're an educator, you know the landscape of how we measure student success is literally always evolving. Today, we're opening up a brand new educator's toolkit, and it's based on some incredibly insightful research into mathematical pedagogy. We're going to look at how we can move away from just testing what students don't know at the end of a unit, and instead use daily active assessment to genuinely guide their learning journey. So I want you to think about your current classroom practices for a second. When you assess your students, are you taking a snapshot or are you streaming a video? It's a surprisingly simple question, but the implications for how your students actually learn mathematics are profound. Let's break down exactly what this means. Consider the traditional digital snapshot. That's your summative assessment or assessment of learning. Think of your classic end of chapter test. It generates a single score, right? It just tells you what a student knows at one static moment in time. But contrast that with streaming video. That's formative assessment or assessment for learning. This is a moving picture. It continuously checks a student's development during the actual instructional activities. And honestly, when it's implemented well, this streaming video approach is absolutely one of the most powerful influences on student achievement. Why? Because it provides targeted feedback to improve instruction while the learning is still happening. Let's look at what this streaming video looks like in a real classroom. Imagine giving a third-grade class a word problem, something like, Lindy has 34 shells and Jessie has 47. How many shells in total? Now, one student might immediately draw an empty number line. If you watch them work, you'll see them make a tick mark at 34, then jump 4 tens to 74, jump 6 to 80, and then jump one more to 81. As a teacher observing this, you aren't just seeing a correct answer of 81. You are literally watching a streaming video of their active reasoning. You are seeing their underlying place value logic and their fluency with tens and ones play out in real time. But to capture those streaming videos, we need the very first method in our toolkit, mastering professional noticing. This isn't just, passively watching your class. It's a systematic three-step process. First, attending. You notice everything, from a student counting on their fingers to the specific models they decide to build. Second, interpreting. You analyze what those actions actually mean about their conceptual understanding. And third, deciding. You use that interpretation to plan your immediate next instructional steps. Now I know what you're thinking. Trying to do this for a whole class feels completely overwhelming. So here is a highly valuable sanity-saving secret. Focus your anecdotal notes on just 5 specific students a day. Systematically observing just 5 students a day using these steps reveals invaluable instructional data over time, completely without burning you out. I absolutely love this quote from educational researcher Phil Darrow. He says, a system that keeps telling us we are not there yet is like a kid in the back seat whining, are we there yet? Come on, we've all been on that car ride. If our assessments only ever point out deficits, if they just slap a big red X and say, wrong answer, you aren't there yet, we aren't actually helping the student navigate to the destination. We desperately need tools that give us good, solid information about the direction to travel, not just the distance left to go. And that brings us to the second tool in our kit, the diagnostic interview. This is a one-on-one investigation of a child's thinking about a specific concept, and it usually lasts just 3 to 10 minutes. You pose a task, and you listen to their strategy. But here's the most critical thing to remember, and actually, it's often the hardest thing for us as educators to do. This is strictly an assessment opportunity. It is not a teaching opportunity. You have to fight that urge to jump in and teach. Your goal here is to unearth their reasoning, pinpointing exactly why they are struggling before you ever try to fix it. Now, mastering these interviews means mastering some pretty challenging rules of engagement. First, you must avoid revealing whether an answer is right or wrong with your face or your tone of voice. You must avoid interjecting clues, and most importantly, you have to master the double wait time. Okay, it goes like this. You wait silently after you ask a question, and then when they give you an answer, you wait silently again. That second wait time, it's absolute magic. It naturally encourages the child to elaborate on their initial thoughts and provides you with a much, much deeper view into their mathematical mind. This example brilliantly illustrates why these interviews are so vital. Imagine asking a student to write the number for 3 ones, 100, 5 tenths. A student who lacks solid place value understanding will often just write the numbers in the exact order they hear them, 3, 1, 5, 315. On a standard multiple choice test, boom, you might just mark this wrong and assume they don't know 3-digit numbers. But in a diagnostic interview, asking them to simply explain their thinking unearths a massive aha insight. You realize they have a naive understanding where they are just tracking single digits chronologically, completely missing the actual place values.
That kind of diagnostic insight leads us directly to the third tool in our kit, the translation task. A translation task requires students to demonstrate their understanding of a single concept using multiple representations. If a student can translate an idea from a physical model over to a written equation and then to a real-world story, there is a much better chance that the mathematical concept is forming correctly and integrating into a rich, sturdy web of ideas in their head.
Building a translation task is actually highly practical. You can just give students a template with 4 quadrants. Start by giving them an equation, let's say a fraction addition problem. Then they have to write a matching word problem for it. Next, they illustrate that problem with drawings or manipulatives. Finally, they write out a clear explanation of their thinking process. Here's why this matters so much. Shifting between these 4 phases completely prevents rote memorization. You simply cannot fake understanding when you have to translate it across 4 different mediums. They have to truly grasp the relational meaning of the math to complete the task. All of these tools, the noticing, the interviewing, the translating, they're all building blocks for the ultimate mindset shift we want to see in the classroom. We want to move students away from a performance orientation, where they are just fixating on getting the right answer so they look smart, and move them toward a mastery orientation. In a mastery orientation, students actually use feedback and their own mistakes as active stepping stones to grow their understanding. And this is really where we hand the reins over to the students, empowering them to take true ownership of their own learning. So to build that mastery orientation, we need to shift the heavy lifting of assessment from the teacher right back to the student. We can do this through highly pragmatic daily self-assessment strategies. Think about deploying pre-assessments to catch confusion early, or just using quick exit slips at the end of lesson. You can ask open-ended reflection prompts like, hey, what is still causing you difficulty with fractions today? Have them analyze their own errors, or even engage in peer error analysis. These strategies teach students to monitor and adapt their own learning. It helps them identify what they need to work on long before that final summative test ever happens.
Now, to support this kind of student self-assessment, transparent rubrics are an absolute must. A rubric shouldn't be some secret grading key locked away in the teacher's desk. It's a roadmap. By providing clear, predetermined scoring criteria, using language like above and beyond, on target, or not there yet, you are showing students exactly what excellent performance looks like right from day one. When you post a rubric prominently and discuss it openly with the class, it gives students a very clear, objective target to aim for in their own self-reflection.
So we've unpacked the toolkit: professional noticing, diagnostic interviews, translation tasks, and self-assessment rubrics. Assessment absolutely does not have to be a static, stressful snapshot at the end of the road. It can be a dynamic, fascinating, and incredibly helpful video stream that guides your teaching every single day. So I'll leave you with this question. How will you change your classroom tomorrow to start streaming the video of your students' learning?